Hello everyone. In this video, we will take some examples of converting a decimal number system to a hexadecimal number system. In lecture 4 of this course, we did study how to convert a decimal number system to a binary number system. Now we will use the same method to convert the decimal number to the hexadecimal number. To convert integer number from decimal to hexadecimal, divide the number by the base 16 until the result finally becomes 0. Traverse the remainder from bottom to top to get the result in hexadecimal. Let us take an example. Convert the decimal number 372 to hexadecimal. Make two columns, integer and remainder. Divide 372 by the base 16, gives 23 with a remainder 4. Then divide 23 by the base 16 gives 1 with a remainder 7. Then divide 1 by 16 gives 0 with a remainder 1. Now traverse the remainder column from bottom to top. So the number 372 in decimal is equal to 174 in hexadecimal. Let us take another example with decimal point. Convert the decimal number 85.76 to hexadecimal. For convenience, we will take the number as two parts, the integer part and the fractional part. Then we add the two converted parts together. First, we will convert the integer part of the number, which is 85. Make two columns, integer and a remainder. Divide 85 by the base 16 gives 5 with a remainder 5. Then divide 5 by the base 16 gives 0 with a remainder 5. Traverse the remainder column from bottom to top. So the number 85 in decimal is equal to 55 in hexadecimal. Now we will convert the fractional part of the number, which is 0.76. To convert a fractional number from base 10 to base 16, multiply the fractional number with 16 until the fractional number finally becomes 0, or stop after required decimal places. Traverse the integer from top to bottom to get the result in base 16. Make two columns, fraction and integer. Multiply the number 0.76 by the base 16 equal to 12.16. So the integer part is 12, which is equal to C in hexadecimal, and the fractional part is 0.16. Then multiply the number 0.16 by the base 16 equal to 2.56. So the integer part is 2 and the fractional part is 0.56. Then multiply the number 0.56 by the base 16 equal to 8.96. So the integer part is 8 and the fractional part is 0.96. Then multiply the number 0.96 by the base 16 equal to 15.36. So the integer part is 15, which is equal to F in hexadecimal, and the fractional part is 0.36. Then multiply the number 0.36 by the base 16 equal to 5.76. So the integer part is 5 and the fractional part is 0.76. Then multiply the number 0.76 by the base 16 equal to 12.16. So the integer part is 12, which is equal to C in hexadecimal, and the fractional part is 0.16. Multiply the number 0.16 by the base 16 equal to 2.56. So the integer part is 2 and the fractional part is 0.56. Multiply the number 0.56 by the base 16 equal to 8.96. So the integer part is 8 and the fractional part is 0.96. Stopping at 8 decimal places, traverse the integer column from top to bottom. So the number 0.76 in decimal is equal to 0.C28 F5C28 in hexadecimal. Now we add the two converted parts together. The converted integer part was 55 plus the converted fractional part, which is 0.C28 F5C28. And this is equal to 55.C28 F5C28. So the number 85.76 in decimal is equal to 55.C28 F5C28 in hexadecimal. This course is sponsored by the Logic Kit app, where this app is made for teachers and students who are involved in studying the computer. With the Logic Kit app, you can learn and solve number systems and boolean algebra with step-by-step solutions. Let's use this app and convert a decimal number to a hexadecimal number and see how this app explains the steps. In the Convert Number section of this app, we select the input base, which is 10, and the output base, which is 16, and write a decimal number, for example, 865.329. As you can see, the equivalent hexadecimal number is 361 0.5439581. Now let's see the steps. As you can see, the app first converted the integer part of the number and doing the calculations with explained step by step that you can follow to understand the solution. Then you see the steps of how to convert the fractional part of the number. Also, the steps are explained very well. At the end, it added the two converted parts and give the final solution. This app is giving you the ability to convert from any base to any base up to base 36. Also, by this app, you can find the complements and do arithmetic between numbers in different bases. In the Boolean algebra section, you can do a lot of things like minimize the functions, solve the Karnoff map, deal with truth table, and many other things. I will leave the link to download the LogicKit app from the App Store in the description. Don't forget to subscribe to the channel and follow us on social media. All links are in the description.